Hello Marauders, we're continuing our graphs of trig functions. Today we're going to do tangent and cotangent, and they're pretty simple. No reason to get complicated. Okay, so I've been asked to graph tangent. So let me grab my trig sheet. Here's the last two graphs. Tangent, looks kind of funny. This is a cycle or a period, and you see it happening over and over and over. Well, cotangent's kind of similar. And what you find here is these asymptotes. That's the kit. That's the trick there, to find the asymptotes. So how do I do that? Let's turn over. Remember we had a rule for sine? Here's tangent. Graphing tangent and cotangent. The trick is to find the asymptotes, the imaginary lines a graph gets close to. And you just look at everything in here, bx minus c, whatever's here, you just set it to plus or minus pi over 2, which is 90 degrees. Here, let's try this out. So I see tangent of x. So I'm going to draw my graph here. And what I'm going to do, it says to take whatever you see. Sorry, it's a little focus. We've lost it there. Tangent, bx minus c, and make it plus or minus pi over 2. And we're losing the focus here. And we're going to be out of focus today. Okay, we're in focus. So I take everything that's here. This is the whole bx minus c. I got to get a different pen. And I set whatever's here equal to plus or minus pi over 2 to find the asymptotes. So just like I see here, whatever's in here, put plus or minus pi over 2. In this case, all we have is x. This is like 1x. So we're going to take this right here and go, okay, so 1x could be pi over 2, and then you do it again with a negative. 1x is negative pi over 2. Well, that's it. It's already solved. So pi over 2 and negative pi over 2 are my asymptotes. So I go down here. This would be 0. And I just go over here to where pi over 2 is. And negative pi over 2. Well, let's see, we have to go backwards. Negative pi over 2. You draw your asymptotes. And then you're going to draw the tangent graph, which looks like these neat little waves. So you just start here, you go right through 0, then right back up. And you get really close to the line, but don't cross it. This is the idea. Now, how was this created? If you want to sit here and go, okay, 0 degrees, 0. 0 degrees is at 0. I could go 30 degrees, a little bigger, 45 degrees, 1, 60 degrees, gets a little bigger, like 1.7, but at 90 it says undefined. So these dots get a little bigger as you go, but instead of sitting there plotting them all, just do that. Now, often they like to have you do it one more time. So what you do is, notice there's these two asymptotes right in the middle of 0. So what you're going to do is make 2 lines and then count again. This is the length of one period. So 0 to pi over 2. So I'm counting by pi over 2. That's how far it was away, or 90 degrees. So let's see, I would just do 2 pi over 2, 3 pi over 2. Of course, I could just change that to pi. And then every 2 little things, you're going to make an asymptote again. And you could just do this over and over and over. There you go. And you just keep going. So remember, this is one period. Actually, this whole length is a total length of pi. Pi over 2 minus pi over 2. The whole period's pi. But all you gotta do is just find the asymptotes, do this, bx minus c, whatever's in here, put plus or minus pi over 2, that finds the 2. If somebody throws something in front of this problem like a 4 for the amplitude, that doesn't worry about it. It just means halfway through, if you were to, make that little scale here, instead of going to 1 and -1, this would just be 4. It just means this dot here is at 4, and down here is -4. So not really a big deal. It's going to look exactly the same. Okay, what if somebody threw something a little fancier at you? Said, okay, how about y equals, and I just put something like, okay, tangent 2x. Okay, so try to get technical. Don't worry. Make your line. And then I'm just going to take all of whatever's here, whatever this is, this whole bx minus c, and again, just set it to plus or minus pi over 2. So in this case, we have 2x. So we're just going to take this 2x. I'm just going to do it down here for a change. I'm going to go 2x is pi over 2. Now do it again. 2x is negative pi over 2. Solve each one. You could divide by 2. Some people like to cross multiply and go 4x, 2 times 2. 4x is pi. Divide by 4. Okay, so x is pi over 4. Do it again. 4x is negative pi. Divide by 4. X is negative pi over 4. Oh, okay, not too bad at all. So I'll just go pi over 4. Negative pi over 4 will be back here. That negative a little bigger. Draw some asymptotes. And then make that neat little shape right there. Then back up, get really close. And people usually like you to do it one more time. So, okay, make 2 lines. 1, 2. That's the important thing. That's where people forget. See, there's 1, 2, 1, 2. Make your next asymptote at 2 spots over, not right here. Go 2 spots. That way, when you draw it, remember to go to the middle and then back up. So that way you get this little middle spot. And some people even like you to label that. Let's see, here is 0, 1 pi over 4, okay, 2 pi over 4. This must have been 3 pi over 4. If you want to do it in degrees, you can. Why do people like to do 2? If I looked at this chart here and actually sat here and did it the hard way, I get these numbers, undefines the asymptote, and these are the numbers backwards. But you notice these numbers right here? That's these up here. That's the same ones again. And then these are these. So it just happens again if you're going to do the full 360. That's why a lot of people like to do here and here, and that's why it repeats. And you could also pull it up on Desmos. Here it is in Desmos. I typed in tangent of x, and you see it over and over and over. I could zoom in and look at it much closer, and you kind of go, where is this? If I put in like y equals, and for pi, I'm just going to go 3.14 divided by 2. There's your pi over 2. Whoops, not y, x. See, that'd be like an asymptote. I could just put these in at every pi over 2. Okay, so now let's try cotangent. That was tangent, cotangent. It's almost the same thing, but look, they're going the other way. And the other thing that's different about cotangent is that instead of taking this whole thing and putting pi over 2, you make one at 0 and one at pi. So you actually got to figure out 2 of them. It's just a little bit off than before. You see how this was pi over 2, negative pi over 2? See, this guy's at 0 and pi. A little 0 is missing there. Maybe I should just put 0 right there. Okay, so we're going to try one out. There was tangent. Move this up. Here comes cotangent. Okay, so we'll do a basic one. Cotangent of x. Draw a line. Take all of this stuff, whatever it is. Here I just have 1x. Set it once equal to, what did we say if you forgot? 0 and pi. Because you got to get 2 asymptotes. You set 1 equal to 0. We just have 1x here. X is 0, x is pi. So here's 0. Here's pi. Take your asymptotes. And when you draw a graph, don't forget, put a thing in between, because we always need 2 spots so you can hit the middle. And whoa, wait a minute, cotangent, the opposite. backwards. Remember cotangent, you might remember cotangent is just 1 over tangent. That's why it's kind of like reversed, upside down. In fact, if you look at our old graph, 0. Could you turn 0 upside down? No, it's undefined. If you turn undefined upside down, it's 0. So it just kind of got flipped over. Put little arrows to say it keeps going. And then do another one. Remember, 2 lines. That's what people forget, 2 lines. And what did I count by? What's in between here? Let's see, 0 pi. This must have been half of pi. And so that's 1 pi over 2, pi over 2, pi. This must have been 3 pi over 2. This must have been 2 pi. So there's your next one. Your asymptote. Draw your line. And don't worry, somebody, like I said, somebody put 10 here, like a 10 in front of it for the amplitude. All it means is halfway through here, this would be at 10. And halfway through here, this would be negative 10. It looks the same. Okay, last one. Let's do it fancy. I'm do some stuff there. Okay, here. Okay, here's a fancy one. How about cotangent x over 2 minus pi? Oh no, it looks confusing. Don't worry, it's not. So again, all you gotta do is just take the whole thing, the whole mess, make it 0, make it pi. I'll zoom this in a little bit. So all you do is take the whole thing, whatever you got. I'm gonna write it here. Take that whole thing, make it 0. Take the whole thing, make it pi, because that's what we're supposed to use for cotangent. Solve each one. Let's see, how am I gonna solve this? Let's see, I'll move the pi over. So now it's x over 2 is pi. Added the pi. Okay. Oh, cross multiply. Now I have x is 2 pi. There's one of your asymptotes. Do it again. Move the pi over, add pi. Okay, x over 2 is pi plus pi, 2 pi. Cross multiply, 2 times 2. X is 4 pi. Easy peasy. Here we go. So I'm going to draw one at 2 pi. I'm not going to put the 0 in because I'm not really sure where 0 would be. So let's go. There's 2 pi. Here's 4 pi. Those are your asymptotes. Put your little asymptotes. Don't forget, put a line in between because you got to have 2. That's the main thing. That's where I see the mistakes. Cotangent, backwards, through the middle. Yeah, like that. Make that nice little curve there, like a little slide. Then do another one. And then what was this middle? Oh, 3 pi, 2, 3, 4. Okay. 2 lines, 2, 3, 4. That's why you got to have the middle so you can count. 3, 4, 5 pi, 6 pi. Oh, okay. Here's the next asymptote. So here's like a period. Here's another period. And here's, whee, there we go. And now you know how to do it. So now you can do 4.6. You can do the homework. There it is. And even explain it out, nice little steps as you go. You don't have to worry about getting real technical there with the little 3, but just in case you wanted to. And you can try these. There's some cotangents, tangents. And don't forget the neat ones we did the other day. All right, see you guys tomorrow. Have fun and we'll be ready for like a test. And here's one last little summary. So once again, here's tangent. Okay, tangent, remember to use these. Pi over 2, negative pi over 2. Whatever's in here, solve it to find where these are at. And if you had cotangent, remember we use 0 and pi. And whatever's in here, you might have to solve it to get these two people. Tangent, you go this way. Cotangent, go that way. All right.